A block of wood of mass 0.5 kilogram rests on a rough horizontal table. Find the acceleration of B. Okay. I mean, personally, I can't be bothered to read a long question like that without seeing what the first part of it actually is, you know. The acceleration of B. So, which way is B moving, up or down?
Down.
Yeah.
A coefficient of friction.
Because the system is released from rest. After release, B descends a distance of such and such. Let's not worry about the distance. Okay, so what other information have we got apart from the mass of B? Are we going to have to look at the friction of, you know, block A?
Yeah, I think so.
It's only 3 marks now. No, I think we can do it by, on account of B descends a distance of 40 centimeters in half a second. So
you just work out with that, can't you?
With a Suvat, which one?
Can't you just say acceleration equals change in velocity over time?
Indeed. Whoa, hang on a minute. Do we know the change in velocity? Do we know?
Well, I mean, we could say if it descends 0.4 meters in how long?
I don't think we can use this one again, can we? The v squared, because we don't know the final velocity. We do know the initial velocity is 0. We do know the s, and we're trying to find the a, but we don't know the v. Okay. On the other hand, all the other ones involve t. Oh, that is, we do know t, sorry. But we don't want the top one for the same reason that we don't want v and we don't know it.
I feel like you might be able to do it just through without looking at that.
Without just do that.
What was the maybe? I mean,
I don't think we can do it without
0.4 meters.
You know, without a Suvat amount of work.
What was your idea?
Sorry?
What was your idea?
Suvats. Choosing a Suvat. If we know which variables of Suvat do we know? Or are involved? A for acceleration.
S for displacement. U for initial velocity.
Yeah.
Yeah,
true. We know the initial velocity is 0.
And time, 0.5 seconds.
So A, S, U, and T, that's enough for which one?
S equals UT plus half AT squared.
Exactly. Yes. So S equals UT plus half AT squared, i.e. S is
displacement.
Taking a value of
0.4 meters.
0.4. It's always meters. Let's not use units in mechanics if we can help it. As long as the units are meters, seconds, kilograms, newtons, it should be all right.
And we can just say half times a times 0.4.
Yeah, because u is 0. Quite right.
0.5 even.
Half a times the time of half. So 0.4 equals a quarter a. So a itself will be 4 times 0.4, won't it?
Yeah. So it's just an eighth of a. Is that what you said?
What? Well, do you see what I've got? I'm saying s 0.4. Oh, yes. No, I take correction. On account of, I forgot the square. Well done. T squared.
So,
So an eighth of
so
a equals that. So we need to, a is going to be 8 times 0.4.
yeah, I got 16 over 5
Or 3.2.
or 3.2.
Excellent. Yes, 16 over 5 is, I should admire that even more, being a fraction. Good. The tension in the string now. If I say we are looking at an equation of motion, does that help? Can you remember what an equation of motion is?
An equation which, I don't know, it's always moving.
It's where the force with which something is actually moving, otherwise known as ma, because it's the rate of change of momentum, because it's the derivative with respect to time of mv, isn't it? Do you see that that's what ma is? The derivative with respect to time of mv, the momentum. So it's the increase in momentum of an object is always equal to the sum total of forces applying in the same direction. And that direction is downwards, acceleration. So these forces must be considered downwards. And they are what? What are the forces looking downwards?
Gravity.
Of how much?
Of minus 9.8.
Well, we're looking down, so it's not minus, is it?
Okay, 9.8.
But it's the 9.8 is just the acceleration due to gravity.
9.8 times 0.8.
Yes. And what other forces are acting downwards?
Weight.
That's that, isn't it? That's the weight. 9.8 times 0.8 is the weight.
What other forces acting down? None.
Tension acting in reverse.
Yeah.
So the two forces acting here are weight and tension. If there was no tension holding it back, ma would be just equal to the weight. The force with which it actually gained momentum would be equal to the weight pulling it down.
What about the friction?
Air resistance?
Well, I think that.
But don't forget, B only knows about A through the tension.
So there's no friction.
There is, but B, you know, that's why it's called mechanics. We think the universe is a machine, and there's no spooky action at a distance, as Einstein called it. Aren't I? Sorry if I sound clever today. I'm not, but Newton thought that the universe was a machine where things could only affect each other by touching.
Mm.
So, you know, the effect of the friction at A is communicated through the wire.
Yeah.
So B, all it knows about is gravity pulling it down, which kind of contradicts the other stuff I said. But yeah, gravity is a bit spooky. But yeah, it doesn't know about A except in as much as it's joined to A, and so all it knows about is the tension of that join.
Mm. Okay.
So MA equals that minus tension. But we know MA, don't we?
Yeah, that's 0.8 times 9.8.
0.8 times what?
9.8.
No? The actual acceleration is what we want here. I know we talk about the acceleration due to gravity as though it were accelerating. That's the acceleration, that's the would-be acceleration due to gravity. 9.8 is what the acceleration would be. But the actual acceleration is?
9.8 minus t.
Yeah, no. MA is going to be equal to 9.8 times 0.8, the weight minus t.
Oh.
That's the weight, isn't it? But the actual acceleration, which we worked out in part A, is
3.2.
3.2. So 0.8 times 3.2 is what's equal to 9.8 times 0.8. So t equals, whoa, I put a 0 in there for some reason. So t is equal to, if we make t the subject here, we've got 0.8 times, might as well take it out as a factor, mightn't we?
Yeah.
Is that right? If I bring the t over to the left and then subtract 3.2 of the 0.8 on the right, that is what we've got, isn't it? So it's 0.8 times 6.6. Would you agree?
Yeah, something like that. Yeah.
Well,
yeah. Yeah,
well,
we got the same thing. We got the same thing.
If I was a bit flash with the factorizing in one step there, by all means,
I think that's what you've done. I think that's what you've done.
Do it a different way, and we'll compare notes. But this way, we get doubling that 3 times. Gosh, 132, 264.
You did get it right.
Good.
It's 5.2.
So double 264. Yes, 528. So 5.28, did you say?
Yeah.
Great. So that's the tension in the string. Now, what happened there? It was an equation of motion where you put MA, think of it as the force with which something is actually moving. The force with something with which something is moving is its rate of increase in momentum.
Yeah.
And it makes sense, doesn't it, that it's going to be gaining as much momentum as things are pushing or pulling it with.
Yeah.
It's going to be equal to the weight minus the retarding force of the tension. The value of mu now the friction.
Okay. Find the value of u.
And we do want an equation of motion for block A, basically. So look at this equation of motion. See if you can do something similar for block A. See if you can set MA equal to the forces acting on block A.
Okay, well, MA would equal 0.5 times 0.8. No, 9.8.
So A is descending freely under gravity, is it?
No, but it's attached to something that is.
Is B descending freely under gravity?
No, because it's got tension.
Yeah. So which of A and B are going to be moving with the greater acceleration?
Well, they both move at the same speed.
And also the same acceleration. Yes, exactly.
Yeah.
And that acceleration is?
That acceleration is 3.2.
Yeah. So 0.5 times 3.2 is what's got to be equal to the sum total of all the forces acting in which direction this time?
To the right.
To the right, horizontally, yes. So what are the forces acting horizontally to the right?
There's friction acting against it.
Against it, yes. Absolutely.
Then there's
Negative friction, which is at a maximum, isn't it? You can put F max. It's usually a side issue, so maybe I shouldn't bring it up in this case. But you know that the friction is at a maximum when the object is actually moving.
Right.
What other forces are acting to the right?
There's the force of, I don't know, would you call it B?
Sorry?
The force of B pulling it?
Which is which force?
Which is gravity.
No, again, how did B know about A?
Because it's connected to it. Because it's slowing it down.
So the only force it got from A was?
Slowing it down, deceleration.
Yes, in the form of which force?
Friction, tension.
T.
Tension.
How does A know about B?
Tension.
Only through the wire, yeah?
Yeah. So plus T.
Yeah. Any others? Any other forces acting horizontally?
No.
No. Quite right. Oh well then, we can solve for F, can't we?
Yeah, so 1.6.
What was T? 5.28. I see, that's your 1.6, yes. So that equals tension minus MA, which equals 5.28 minus 1.6, you're right.
Minus.
So, so 3.68, I think. Yes.
So 3.68 equals,
Great.
yeah.
Good.
Yeah.
And now how do we find mu?
Mu equals F over R, and the
Yeah.
reaction force there
Right.
would be, it will be 0.5 G.
Yeah.
So F over R would be 3.68 over 0.5 times 9.8.
Yeah, good.
0.75.
Great. Oh, it's 3/4, is it?
No, it's longer than that, but
I see.
yeah.
Very good. And state how in your calculations you've used the information that the string is inextensible.
Because there's no stretch in the string.
No, that's what it means to say that it is inextensible. How have we used that assumption that there's no stretch in our calculations?
By the movement of B, by the movement of B affecting A, right, and T
You're
being
not there yet. How can we get that mark?
so by the only way they are able to affect each other is through tension.
Oh, yes. Yes. So the answer is, I mean, that would probably, and it's my fault if that's slightly off the point. Hey, why is that? I thought that was. Jesus, what's going on there? Yes, if that's slightly off point, it's my fault. The way I was discussing that, but basically the answer is we've used it by setting both values of t equal and both values of a equal.
Yeah.
By assuming that the tension is the same for A and B, and also the acceleration is the same for A and B.
Yeah.
Either of those or both for that mark. Why is I've got a giant arrow then? Okay. Right, good. A fixed wedge has two plane faces, each inclined at 30 degrees to the horizontal. Right. And it doesn't look like 30 degrees, does it? Are they trying to put us off the scent here? Make it look more complicated than it is? Because if it's 30 degrees, then we know what the ratios are immediately, don't we?
Well, we know it's an isosceles triangle.
Yeah, but if it's 30 degrees in particular, then we know these ratios are. What are the ratios?
4 and 5 and 3.
No, bad luck. But 3, 4, and 5 is something to look out for, but it doesn't give you nice angles. But 30 degrees is what time on the clock?
2.
And from the fact that from 2 o'clock to 4 o'clock makes a nice equilateral.
Oh yes, 60. So we know that's.
Well, we know that. Yeah, we kind of already knew that they were all 60, but from the fact that it's an equilateral, we get what ratios of the sides? What's a nice ratio?
I can't remember.
No, don't remember. Think about it. Look at it. This is, you know, these things need
Oh yeah,
thinking
okay.
about
So
every time, not just
it's
memory.
like a half one.
Yeah, yeah. So if that
Or
was 1, that would be,
that would be 2.
yes. In a 30-degree right-angled triangle, the opposite is half of the hypotenuse. Hence, sine 30 is a half.
Right. Okay.
On the unit circle, you know, if I can improve on that. What we're saying is that the sine coordinate of that point, it's halfway up the sine coordinate up to the top, isn't it?
Yeah.
When you're at 2 o'clock.
Yeah.
Anyway, back to the problem. By considering the motion of A, and what is that motion, can we guess? Probably tells us which way are the particles moving when they're released.
By considering the motion of A in terms of M and G, wait, find in terms of M and G the tension in the string. Where's G? Oh, G is in gravity. Okay.
But just looking at the diagram, which way are the particles going to move when they're released?
Down to the left.
Yeah, partly because A is heavier, and partly because it's smoother as well.
Yes. Yeah. Yeah. Exactly. Didn't even see that.
Right, but considering the motion of A, find M in terms of G. So it's probably an equation of motion. Again, being what kind of equation?
Being a Stewart equation.
No. What? Remember, we wanted an equation of motion for each of the 2 parts of this. What's the essential feature of an equation of motion?
Force equals mass times acceleration.
Yes, think of it as sum total of all the forces applied is going to be equal to the force with which it's actually moving, the MA. So that's probably what we're doing here too. I don't know. It's only 3 marks though. The meat of it is part B. So I'm surprised if we have to think about friction yet. Maybe you're right that it's just a suvat as opposed to an equation of motion. Find in terms of mass, and it says the motion of A, not B. We shouldn't have to think of, okay. So what else are we told? Oh, we're told the accelerations. So yeah, just to see that probably. No, hang on. An equation of motion. Okay. Right, what's an equation of motion again?
Force equals mass times acceleration.
Okay. So I would do it the other way around generally.
Right.
Say mass times acceleration first equals sum total. Now, which direction is the acceleration? Down the slope.
Yeah.
So the forces that we're summing up are going to be heading down the slope. So what are all the forces looking down the slope that are being?
Okay, well there's the weight, which is
Yes. And how much of that weight is acting down the slope?
3m. Hold on, let me think.
So the weight acting vertically is how big?
The weight acting vertically. I don't know how you've got. You mean it? I don't see how there's anything acting vertically, like straight up. But I could see how you've got a reaction force of
Which way
3m.
does weight not actually act? If it's not a silly
Weight,
question.
huh?
Which direction does weight act in?
Weight acts down the slope.
No, weight. Well, pardon me for
Well, it acts straight down. It acts straight down, but then
does.
you've got it's going to be going into the slope and down the slope.
Oh yeah, we're going to resolve it that way and that way. But look,
Yeah.
I've spoiled the fun. This is the difficult bit, what I've just done here, which is what you must learn to do,
No, yeah.
which is to resolve in the appropriate directions, usually parallel with the slope. But there's a dozen different mistakes you can make here. You might go like that. You might look at that and say, okay, well, there's the slope. You might, I don't know, there's all sorts of, you really want to try and get into the habit of thinking of resolving carefully parallel and perpendicular to the slope. So what's the actual weight?
3m times 9.8.
3 mg, we'll call it for now. So what are these components?
That component is let me think. So that yeah, okay, so that component you got there would be 3mg. No, yeah, it would be 3mg sine 30.
But sine 30 is?
Sine 30 is a half.
And anyway, look, it's the same triangle. So yes, of course, this is going to be half of that.
Yeah.
So how much of the weight is acting down the slope?
3 times a half, 1.5 mg.
Yeah. Good. And what other forces are acting parallel to the slope on the particle A? So we've got, that's acting down the slope, isn't it? So we'll put that positively.
Yeah.
Any other forces acting down the slope?
No.
I think so. What about friction for particle A? How much friction is there for particle A?
None.
Good. So we forget friction for part A. That would be why it's only 3 marks. But we do have to do this equation of motion where MA, which we could be more specific about actually, couldn't we?
We'll call it force.
Yeah, the force with which it's actually moving, but we know the value of it, don't we? In terms of M and G.
Yeah. Okay, well, we've got the reaction force.
We're not going to need that. That would only affect the parallel journey through the friction, which there's none of. But what other force is acting parallel to the slope, apart from this much of the weight?
Tension.
Yes.
I thought you were saying going down.
Fair enough. Yes. So it does have to be minus tension for that reason. No, I just meant in the direction positively or negatively, down or up, but parallel to the slope. But
Okay.
yeah, I totally see. That's ambiguous.
Okay.
So, well, we could, maybe this is interfering. We've basically got MA equals that, but instead of MA, we could have written, well, what is it? What's M?
Mass,
Which is
what is mass? How much it weighs?
well, if
According
you
to
multiply
gravity.
by G for gravity, you'll know the weight. Yes, but what's the mass of A?
3m.
3m, which is a bit ambiguous again, isn't it? Because m here means mass, but
Yeah.
m here means some unknown mass
Number.
value.
Yeah.
But you've got 3m times the acceleration, which they've told us is
Where'd they tell us? Around 1/10g.
yeah. So that's ma, isn't it?
Yeah.
And that's equal to 3/2 mg minus t.
Yeah.
Okay. So t equals
T equals. Well, don't we have to be quite careful here? Because now we've got like a G, an M, and then an M and a G, but they're different.
yeah. I mean, we could simplify the left-hand side. That is probably a good idea, isn't it?
Yeah. Then we'd have 3/10 mg.
Yeah.
But aren't those mg's different?
No. Oh.
Mm.
Oh yeah. Oh. Oh. That's 3. Oh no, they aren't. They are the same. Because look, 3m here. For a minute
Yeah.
there, I thought, yeah, I was using m in the sense of this m here, which we really ought to put capital M so it's not confused. But no, we're okay. This was 3m as opposed to that kind of m. All right.
Yeah.
So
Okay.
it's fine. Because this literally is 3/2 mg. It's fine.
Minus T. Yeah.
So
And
t
then we've
equals
got T equals equals 3/2 mg minus 3/10 mg.
which equals
Which equals 12/10 mg,
good.
which equals 6/5 mg.
Lovely.
Or if I just copy that down quickly.
Of course. I'll send you it.
Equals to T1 over 10. Okay, cool.
Right. Okay. By considering the motion of B now, and again, that's almost certainly a big clue. By considering the motion, they're saying equation of motion, which is what kind of equation?
By considering the motion of B, find the
What kind of an equation is an equation of motion?
I don't know, like a CVAT equation?
No.
What do you mean?
What do I keep calling an equation of motion? And you know, I can see that as a phrase, equation of motion, it doesn't, you know, it doesn't shout its significance. But I want you to be aware of this thing called an equation of motion, which is what kind of equation have we just used 3 times in a row?
Mass times acceleration
Equals?
force.
But that's so devoid of the whole point of it. I know that's what people say, force F equals ma, yeah?
Yeah.
I can't stress enough. It's not about that. Yes, it's got 2 different meanings. Ma is the force with which something is actually moving, yes. But an equation of motion is putting ma equal to the sum total of all the forces in the same direction.
Okay.
All the forces acting on the particle in that direction.
Right. Okay.
Now you know that we've used it 3 times in a row here.
Yeah.
An equation of motion, and I'm desperate to call it an equation of motion. I don't think you're quite picking up on my anxiety about, you know, that's what it is. It's an equation of motion.
Okay. No, I get it now.
You must be conscious that it's ma equals the sum total of the forces in a particular direction. Same here.
Yeah.
And then same, and we just did the same here. And now they're giving us the same hint by considering the motion of B. It's probably an equation of motion. I mean, I wasn't sure of that. I thought it might be a SUVAT, but anyway, an equation of motion, that's where you're putting ma and you're thinking, oh, well, it must be all of this force, but then these forces are acting against it. So you subtract the ones which are acting against it, yeah?
Yeah.
So let's try and do that for B.
By considering the motion of B, find the value of mu.
So for particle B, ma would be what?
M times, we don't know the acceleration, do we?
Do we?
I don't think we do know the acceleration. Wait, surely we must do.
We do.
1 over 10g. 1 over 10g.
So ma equals?
The
mass of B is?
M times,
yeah, the
1
mass
over
of B actually is m.
So 1 over 10
equals
mg, a tenth mg.
A tenth mg. And which way is the acceleration?
Upwards.
Up the slope at an angle.
Yes.
So let's expect all the forces to be oriented up the slope. So positive if they're up, negative if they're down.
Yeah.
Okay. So what are the forces acting on the particle B?
Well, there's the weight acting down.
All right, but then we have to be careful how much of the weight is acting down.
It would be, so the weight is, it would be, the weight acting in parallel with the side of the triangle would be sine 30.
Yeah, but you know, remember that sine 30 is,
Yeah, 1/2.
aha,
So half m is going down the slope,
all right,
and
you said the weight was m, didn't you?
yeah,
Were you abbreviating?
a half m.
Well, that's how much is parallel to the slope. Notice it's the other way around this time, but we've still got weight acting vertically down. But this time, notice how they've switched.
Yeah,
Now we've got a weight of how much?
m.
M isn't weight. M's the value of
mg and mg.
mg. Yeah. But yeah, acting down the slope for particle B,
It's half mg.
half mg is what we want. Good. Right. So that's going to be negative, isn't it? We're looking up the slope. So minus a half mg, that's a good start. What other forces are acting on particle B?
Then you've got well, you said reaction force would be irrelevant. So then you've got
Part A, it was irrelevant, not anymore. Yes.
oh yeah, of course, because you've got so the reaction force will be m cos 30.
Right. In other words, the magnitude of this component.
Yeah.
But you're calling
Yeah.
it m again when you mean mg.
Mg cos 30. Yeah.
Okay. What's cos of 30?
Root
Look at the triangle again.
3/2.
Yeah, good. So this will be
Root 3/2 mg.
and because you know there are no other forces acting perpendicular to the slope, all the other forces are parallel, so zero component perpendicular to that. Therefore, that's going to be equal to the reaction. Yeah?
Yeah. Yeah.
Well, okay, if the reaction is root 3/2 mg,
Yeah.
we can get the friction F max is going to be what?
F max is going to be a reaction force, so mu equals F over R. Are we given mu?
No, we've got to find it now. That's what we're going to find. So that's fine. We'll call it mu.
Okay, well, we know that 1/10 mg will be equal to a half mg plus plus friction. Right.
Well, I think these are both, if you're going to have a 10th mg positive because we're looking up the slope, then I think that the weight component and the friction are both going to be negative because they're acting down.
Oh, okay, yeah, that's what I meant. So minus friction.
And we might as well work out the friction now in terms of mu. Friction equals what in terms of mu and reaction?
Mu times the reaction.
Yeah, which we know is going to be therefore in terms of mu?
I don't know how you'd know the answer to that.
But we've got an expression for R, you see, the reaction.
Oh, okay, so just mu times root 3 over 2 mg.
Yeah. So what we're subtracting, the friction we're subtracting here is root 3 over 2 mu mg.
Yeah.
Okay.
Why
So
don't you do it slightly different? Then you could rearrange for mu more easily if you kept the mu outside, couldn't you?
what, put the mu before here rather than there?
Well, yeah, just because it would make it easier to like rearrange for mu.
Quite possibly, yes. I might have chosen. I'm not sure. Yeah. So how is this line looking now? Is that our equation of motion?
So let's see, we've got the force is going in one direction equal to that was the friction and the weight. Yeah, I think so.
But how would it be moving upwards then? How can the force with which it's moving be positive up the slope if the only forces acting on it are down the slope?
We've got to add something to those. We haven't. Oh, I don't know.
I mean, why have we set a 10th mg as though it's positive? Which it will be, won't we? Won't it? We know m is positive and g is positive, so a 10th mg is positive. So, well, they did tell us that the acceleration would be. They didn't tell us it was up the slope rather than down. Perhaps B is accelerating down the slope, is it?
No, it's accelerating up the slope.
Yes. Why?
Because A is heavier.
Right.
Well, wouldn't you just say that? So
what force are we missing on our right-hand side here? Which is the reason it's moving up, not down.
A, the force of A.
The force of A transmitted through?
Through, what did we get for A? I don't.
No, that's not my question. Transmitted how?
Like, I don't know, 3m sine 30. I don't know, whatever A was, whatever the force of A was.
So, there must be a force that we can write here. Plus which force? I feel I ought to leave that with you for you to ponder. I don't want to spoil the fun by telling you that.
What is it? The tension.
Thank you. Glad I didn't spoil the fun.
Yeah.
You see the point?
Yeah.
Do you see how that's what you were failing to
Yeah. Yeah.
see?
Yeah. I see now. Okay.
Fine. And by the way, we know the tension is what? What's the tension?
6/5 mg.
Yeah. Oh, look, we've only got one unknown. Mu.
Oh yeah.
So you can solve. Also, the mg's all cancel.
Yeah. 1 sec. Let me just copy it down. G plus 6/5 mg. Okay. Okay. So what are we doing now? Rearranging for mu.
Yeah. Cancelling all the mg's as well. I personally, I'd prefer to just not do any rearranging apart from the removing of the mg's for now.
Okay. So you could say -3/5.
Hmm.
So I got mu equals 0.69.
Ah, but you went to a calculator, did you?
Yeah.
Oh, all right. But I mean, well, fine, it's mechanics. So as long as that's 2√3/5, is it?
2/3. Yeah. Yeah.
Fine. So what was the moral of this mechanics lesson?
Remember that forces of motion is mass times acceleration is equal to the resultant of all the forces, and don't forget about tension.
Oh yeah, well the tension was just well yeah. I mean that was a side issue. Yes, you know forces are only transmitted through some contact, and tension might be the only contact.
Yeah.
But yes, the equation of motion. Say to yourself, right, I'm going to form an equation of motion. Maybe two simultaneous equations of motion. Part C is just, I'll leave it with you, to find the resultant of the two tensions. But they're both the same, aren't they?
Yeah.
We were assuming. So in
Yeah.
fact, all you're doing there is looking at that isosceles, 30 degrees down there, 30-degree slope there.
Mm.
We're saying tension, tension. What's the resultant? It's going to be that much, isn't it?
Yeah.
You see why?
Because it's it's in the middle.
Let me show you a nice picture of that. I think I might have it. Why that arrows? Huge. ZX. Anyway, it's a parallelogram of forces. It's a nice example where, well, you could just add them together, but it would
But then
really be silly not to think of it as, I mean, let's do it quickly. You've got, oh, I'm not sure if I need to look at that. Anyway, we get that.
I think I understand what you're going on about. How they're both at the same degrees. I mean, in this case, so
Yeah, absolutely.
the resultant force is just directly in the middle of the two.
Are they equilaterals? Of course they are. In which case the answer is T. Because they're all 60, aren't they?
Yeah.
Oh! Then 3 marks for a rather simple result. Oh, I know how to do it. Oh. Yeah. That's it. Like that. Yeah, they are equilaterals, aren't they?
Yeah.
That's where we are. Because that tension, whew. Yeah, trick question.
Yeah.
Nice. Okay.